Welcome students. Today we are going to see about complexometric titration. First is, what is complexometric titration? It is a form of volumetric titration in which the formation of a colored complex is used to indicate the end point of titration. These complexes are formed by the reaction of metal ion with an anion or neutral molecule or very rarely positive ion. Next, complexometric titrations are particularly useful for the determination of mixture of different metal ions in a solution. An indicator capable of producing a distinct color change is usually due to detect the end point in titration. Complexometric. Complexometry is a volumetric analysis involving the formation of complexes which are slightly ionized in solution like wheat, electrolyte, and sparingly soluble salt. Complex is formed by a reaction of metal ion with either an anion or a neutral molecule. Metal ion is known as central metal atom. Anion or neutral molecules is also known as ligand. Central metal atom, it is the Lewis acid. Ligand, it acts as the Lewis base. Coordinating bond, the bond formed between central metal atom and the ligand is called as coordinating bond. Types. There are three types of complexometric: unidentate or simple, bidentate ligand, tridentate and tetradentate ligand. First, unidentate ligand attached to the metal to one side is called unidentate. Example, cyanide, water. Bidentate ligand metal attached to the two sides. Example, ethylene diamine. Tridentate, the ligand attached to three metal sides. Example, diethylene triamine. Tetradentate, ligand is attached to the four metal sides. Example, triethylene tetramine. Next, chelatation is a complex formed between the ligand containing two or more donor groups and the metal to form a ring structure. Chelating agents, organic molecules containing two or more donor groups is called chelating agents. They are mostly insoluble in water but soluble in organic solvents. Classification of complexometric titration: direct titration, back titration, replacement titration, alkalimetric of metals. Direct titration. In this method, the sample solution of metal ion in the presence of suitable buffer is titrated against the standard sodium ethate solution. EDTA complex must be more stable than M buffer medium. The soundboard is used to determine water soluble. Back titration: addition of known excess of EDTA to the sample. The medium, if buffered, excess EDTA is titrated with the standard sodium of another metal ion, example magnesium and zinc. Replacement titration: when both back titration and direct titration is not possible due to the end point not being sharply enough, then replacement titration is the method of choice. In this method, titration is determined of metal ions, which is done by replacing magnesium or zinc ions from EDTA complex with an equivalent amount of metal ions. Liberated magnesium or zinc ions are then titrated with the standard ethylene diamine tetraacetic acid solution. In this, modern black is used as an indicator. Alkalimetric titration: metal ethylene diamine complex formed by the reaction explains that protein are liberated from sodium ethate, leading to the formation of acid. Masking and demasking agents. Masking agents are the reagents used to prevent interfering ion from reaction with a physical separation. Example, potassium cyanide, fluoride, iodide. Demasking agents: this is a process in which masking substance reverses back to its ability to take part in the reaction. Example, cyanide. Thanks.